Jeez. Yeah, I had these up before and I could see them in a screen view. Oh, there we go. All right. Does this work for everyone? I can like full screen this thing?
I think it does.
Okay. Right there.
So just to check, can you actually hear me?
I can hear you.
Ah, wonderful. Thank you.
Okay, well, we are above the hour. It's time to go. So we need Jabber Scribe. We need Note Minute Taker. We need you to note well. Everyone note well? Raise your hand. Noted? All right. Can we get volunteers here for Jabber and minutes? Not everyone at once, man. Don't overwhelm us. Anybody? I can't find my other screen. Anyone there? Tony, you hear me?
I can hear you.
There we go. So my audio's still coming through. We just don't have anyone ready to do Jabber yet. People disappearing. Jabber user, we have someone on it. So we need to do this. Someone. It's a big crew. Hey man, could you do it?
Jabber?
Yeah.
Okay, so I have to find where is the link.
It's right here.
Can you paste it, or maybe let me see how. Okay, let me get it from meeting material.
The hell?
So the Jabber chat gets mirrored to the chat on the Meet Echo.
Oh, it comes here, then okay, I can track it.
Right. So you just track that window, the chat window, you'll see the same thing.
Okay, I can track from here.
All right. I heard Ron say something. I think it was Ron. Makes sense, though, man? Man, you on it?
Of chat.
All right. This is hard. Audio seems to be kind of intermittent. All right. I think we got that covered. So here's the agenda we currently have. If anything's missing, shout now. We do have kind of a tight time, especially with all the tech bits to work out to make sure this thing goes. But we can make room if something missing. Anything to change, speak up. I guess it's fine. It's hard. I can't even look at people in the room and see them all look at their keyboard and avoid eye contact. Okay. Talk about some status here. We have a lot of stuff backed up, for all the wrong reasons, but here we are where we are. We've got, in fact, Tony, if you can jump into some of these too, because we kind of shared some of this, but we got consensus on the beer bar draft. We're just waiting for the Shepherd write-up, and I think we need some reviews. Holy crap. I think we need some reviews from other working groups as well. TE Arc is actually, we got a Shepherd now. I think it's ready to go last call. We have definitely some issues around the name, which I don't know how much friction that's going to solve, but Greg, speaking as a personal contributor, I didn't think we've ever had acronym police in the IETF before, but maybe that's a new invention. We'll see how that flies. Jump in if you got new info about this or comments or something, go along the way. Beach BLS. I guess there's some issues. We do have a Shepherd now. It should be moving. I think it also needs to be reviewed across working group. So once we clear here, we'll bump it. Same with PIM signaling. I think it also needs clearing from PIM, as does MLD. So we have these all ready to queue. We got Shepherds all for them, which is great. I think if we go through the working group, Shepherd write-up kind of in parallel, we can jump to the other working groups and get their clear before we go to the queue. Anyone agree, disagree, new info on this? Revs, concerns? Wow. This is tough because I don't know if my audio dropped or whether everyone just thinks this is great. All right. These are actually ready for last call. We don't have shepherds for them yet. I do have a couple names had come up before. I actually got more volunteers than needed for the previous list. So I'm going to dig from that, reach out to you and assign these, and then, see how we roll from there. Questions, concerns, issues? Yeah, Stig? How'd that happen? So Stig sent me audio.
Yeah, folks, just don't push the audio button, queue up, and we'll let you into the queue. If too many people push the audio button, the stuff starts to break up. Okay, so there's a queue and there is a button you can talk immediately. Please queue up.
So Tony, where's the queue? I see that comment. Okay,
If
I hear
people
you.
raise their hands, you will see the queue building up.
Where? There we go. See, I see them
That's
building
like-
up, but all I see is a checkbox to close it. I don't see where to open them.
What you mean open them? You can, where are you as chair? You can either allow them on the mic or you can kick them off the mic.
Right. But the question is, how do I do that? Where is the queue? Where can I bring them up?
Move
Oh,
up
you
the
don't
list.
see the queue? I see the queue.
No, I don't see a queue anywhere.
Well,
On
then
the
you-
left list,
Well,
you have to
names are-
scroll up.
Even I see the queue.
Are you on
It's,
the participant button with the 59?
Yeah.
Right, so if you're on the 59 button,
Yep.
then you will see the queue. There's two people sitting in the queue.
Oh,
And
you got to
Stig
scroll to
just-
the top of it. Gotcha.
Yeah,
They hide.
yeah.
All right.
And
Excellent.
Stig
So
just
I've-
grab the mic. So there is the button where you just grab the mic. Please don't use that because then it breaks up, or otherwise just queue up. Okay.
I don't know what that means. Grep the mic? What do you mean?
There are two.
Yeah, there's a close and an open, a green check and a red check.
Right, but when you look at the very top where you are the participant, you have different buttons, and you have a raise hand mic and you have a direct mic. The direct mic is all the way to the right. If you
Okay.
raise hand, you go into the queue. Otherwise, you just start to talk.
Okay, gotcha. We went backwards. Now I'm back looking at my queue again, which was the question. I don't know how to turn on a queue here. I got three options on this. I check one, nothing happens. I can't hear anybody.
No, so if somebody jumps into the queue, I put, well, right now there's two people on the mic, Stick, Tom Hill, right? And Zheng is as queued up. So I kill Stick mic and Tom Hill mic, and I push the OK.
Oh, so you're killing these. Oh,
Of
well,
course.
shit. I'm trying to see what's happening. They're vanishing. Got it. Okay.
Hey, man, I mean, what
question
are you here
is,
for, right?
if someone's
You don't have
on the
kill
mic,
button.
I don't want to kill them. I want to hear them.
Right, so you allow them. So now Stick is in the queue, and you do a little check mark, and then he gets the mic.
The green check
The green check.
did that.
So
He
he's now
disappeared.
on the mic. No, he's not on the mic. He moved into the sending media, or he's on the mic.
Got it. I see it drops down below. See, my thing scrolls down and it disappears when I do that. I got to scroll back up and find them. There we go. All right. So, Stig, say something.
Beer.
That worked. Okay, we got another one. Few song.
Beer 2.
Perfect. Beer 2.
All right.
Good. So that worked.
And Tom Hill.
I like beer as well.
Right.
Look at that. All right.
And Stick
So-
probably confuses his beer with his mic. Stick, redirect. All right.
And Sandy. Huh. It's interesting. So they speak and then they vanish from it. Are you clearing them off of there? I don't know.
Hello?
Well, let's roll. Any more comments on this doc, on these three docs? In status? Okay. Here's the rest of the pile. We got plenty of stuff still in the works. Yeah, name changes. We got a bunch of expired stuff. Kind of dig through and see. I imagine this has got to be resurrected. If there's motivation for this, jump back in. Rex is still there. Yeah, this disappeared, which kind of surprised me too. So if there's motivations to bring this back, these are still rolling. PHP expired, which kind of, I guess it's still sitting in the same queue with the HTML one. So if it rolls, this might resurrect. Problem statement is expired, but it's out there. I don't know if we need to resurrect it. If there's more things to bring up, it may just rot and disappear. I don't think there's no need to take that on to an actual published doc, but it was a working doc for the group. So if there's new problems to arise, we'll resurrect it. Otherwise, it'll die in its case. Use cases is different. We're keeping it evolved in that. I think at some point we'll ship it, but I don't think we're there yet. Anyone think that this is actually cooked? All right. Yeah, I think we're learning as we go, especially we're at the cusp of seeing live deployments. My expectation is we'll see some deployment docs come from here as we learn. So this may stand, this may spawn off some new stuff. We'll see what we learn. Oh, great. Oh, look at that. Came back. All right. In adoption call. So these four actually, been ready for adoption for a bit. I think it was kind of fun to do it this week and kind of pretend this is IETF week and we have stuff to discuss along the way. Plus some of these will be presented today too, which is a good chance to kind of see it as a doc and engage the group. And hopefully we can start making some progress because we have nothing to do but stay home and read now, right? Perfect. And all right. First doc. We got PIM signaling. And let's see, we got the author's the presenter name here. Hey, Human. All right. Human, are you ready?
Good morning. Can you guys hear me?
I do.
Perfect. So next slide, please. So this is going to be a short update. So we did get some of the comments, well, not some of the comments, a large amount of comments from Stick. Me and Man, we went through the documentation. Most of them are housekeeping, and we did correct all those housekeeping items. I did see an email from Stick again yesterday, which I did reply to. All those comments that you had on the email Stick, they are addressed. I did add the INANA in the new version, which I will upload, but I'm hoping that it should be ready and there should be no more concerns. So I don't know whether you have, I know most of the comments are coming from a Stick. I don't know whether you have read the version 9 of the draft. If so, I'm hoping that it's ready to go. That's all the update I got for that one.
Excellent. That wow. Okay, so ready to go. This is this is actually encouraging too. With we got an overlap. You guys know that, right? Most of you guys go to the PIM group as well, but still, there's some people may not get there. So excellent. Him with 9. Stick, if you can clear the notes that are concerned about that. We'll go to finish call and take this to the PIM group before we go to the queue. Anything else concerned? Whom is that seem all right with you? Where we are? We're just looking for Stig's feedback.
Well, I think just to be clear, I think Stig had provided his feedback to Man, and all those feedback were arrived to me through Man. So there was a man in the middle. So I'm hoping that all
Sure.
the procedures were done correctly.
All right. So Stig, I guess we just need to confirm from you that all this, your concerns were addressed in version 9, and we'll roll. All right. Any other questions, comments? All right. Thanks, Human.
Thank you, and I'll give 5 minutes back to the group because of the beer signaling, the MLD signaling. You guys did bring it into the adaptation call, so thank you very much for that. So I have nothing on that one, which was the next
right
presentation.
Most
Yes.
appreciated. Human, Stick, your mic still doesn't work.
What am I missing here? Tony, you trying to get someone to speak?
No, I just said that Stick's mic still doesn't work. Because
Oh,
he tried
gotcha.
to
We're
get on
still
the
waiting
mic.
for him to say stuff. Yeah. All right.
Yeah, thanks.
All right. Well, right. Responses have been good too, Human. So this is going to roll pretty quick. MLDP. So I guess, does this go off to PIM for approval too, or do we have a catch-all multicast group, or is this go off to MPLS? No feedback? Ron?
I think there's somebody in the queue.
Is there? Oh yeah, I keep forgetting that part. There we go. Just with a request for camera though, not audio. Torless. Hello, Torless.
Hey, if I'm not mistaken, MLDP might originally have been MPLS as well.
Yeah, that's what I was thinking. It was maybe an MPLS group. I was waiting to maybe, I mean, sending that to a couple of groups is not going to be a problem. I mean, ultimately, it goes to the ISGQ and the whole IETF reads it. But just having some focused feedback is going to be important. So yeah, MPLS, PIM. Anyone else got ideas? So I was waiting, maybe get an AD feedback on that.
That should be it.
Yeah. Okay. Sounds good to me. Any questions, comments, concerns, frustrations? All right. Next, we have McBride, I believe. Yeah. Hey, Mike, how you doing? A lot of bouncing back. I'm getting the rhythm here. You there, Mike?
I hope so.
All right. And your mic's working. So we got two mics.
You do have two mics, one very handsome and one just a headset. So we did update this draft. It is progressing well. It's about 1.5 years in, and we've made some good progress. Incorporated some of your comments, Greg, as of this week. Actually, thank you for making some comments. And Guion has joined the draft. He's made some good comments, and he's helping us to progress it. So next slide. So Stig and others made some comments some time ago to remove the unhelpful scenarios section, kind of like a use cases kind of a section. So we got rid of those and replaced them with transport independent and native IPv6 models, which I'll share in a minute. We did also something new, hopefully just to make it clearer, and this will be something that everybody needs to review, is divided the requirements into mandatory and optional. We removed some commentary. Down in the appendix, we have summarized the solutions, and the various solutions, and we've removed some of the commentary from the solutions, particular Beer Ethernet. Some of the comments from you, Greg, this week, we've clarified with regards to using technologies to traverse through non-BFR routers, and instead of beer integrated into the IPv6 data plane, which you didn't think was correct, we did change it to what here is in quotes, and made it more understood that it's being integrated into an extension header. Next slide. Stop me anytime if anybody has any questions. The purpose, just as a reminder, is to specify the requirements for transporting packets with beer headers in an IPv6 environment. We do summarize the solutions, but that's not the goal. Our goal is to help the working group come to a conclusion on what solutions to rally behind and adopt outside of our document. Next slide. So one thing that we did do is to, with the approaches, we did, as I mentioned, divide them up into transport independent models and native IPv6 models. So what fits into transport independent model approaches, we feel, is these two drafts. As Tony has mentioned many times, this is something that we don't want to, in this case, leave Beer's layer 2.5, and so in these cases, in this model, an IPv6 tunnel, if you want to call it a tunnel. We can call it something else if you want. Works as a link layer of Beer, and Beer works as a transport independent layer over a virtual link. And then the next slide goes over the native IPv6 model approaches. And there's a couple drafts there that fit that type of an approach, where the beer header, as I mentioned, is integrated into a extension header, and processing of the beer header, the bit string, is implemented as part of the extension header processing. So we kind of categorized these different approaches into different models, both good models, both very appropriate, but just different. Next slide. Another thing that we've done, as I mentioned, is we've taken the requirements and put them into buckets. Since there's a lot of requirements, we've, in the course of a discussion, thought, okay, let's put many of these into a list of mandatory requirements and then others in optional. And so this is what we've done. And so the mandatory ones are, the solution needs to be layer 2 agnostic. It needs to support the beer architecture. It needs to conform to the existing IPv6 8200. Support deployment of non-BFR routers. Support inter-AS multicast deployments. Not required.
Yeah, can I ask why that would be considered mandatory?
It may not be, but it seems like as for future deployments of this solution that you would want it to have, you would want that solution to be inter-AS.
Sure, but we don't even have an inter-beer domain solution. So going between two beer domains, between two ASs, they don't share a bit set at all. There's just an ABR function between the two. There's nothing in the encap encode that's actually inter-domain.
Okay.
So I'm kind of, as a mandatory requirement, I can't even define those requirements. So it seems kind of a bit of a stretch to call that mandatory. I think it'd be great if there were some mechanisms in the solution that facilitated that, simplified it in some way. That's great. But again, like I said, inner beer requires an ABR function as it is. You leave it completely decap, re-encode, re-encap, and come back out the other side. There's nothing in the transport that I see that facilitates that yet. But if you got something, great. Let's keep it off the mandatory list until we have some consensus on that.
If others agree with that, then we will certainly do that.
Words like this make it tough. Just going to the next line, support simple encapsulation. Simple, I don't know what would define simple versus, because honestly, what I'd say simple encap is take the existing payload and put an encap on it. These two solutions don't do that. One of them encaps the beer packet and forwards it. One takes the data packet, encodes beer information into the V6, and then encaps, which is, I wouldn't call that simple encap. That's encap encode. So if you put that as a requirement, as mandatory, you kind of rule one of those out already from my chair, my seat, not chair group. I'm just my individual contributor position sitting right here. Support deployment security. Well, security is kind of an umbrella for all of IETF. Everything comes through and reviews that. I don't think a particular, I guess.
Yeah, the solutions drafts typically do have a pretty robust section on security, and so I think that it wouldn't preclude any of them from being mandatory. I think that's a fairly straightforward requirement, but again, others can chime in. I'll send it to the list and see if anybody.
Yeah.
Why support hardware fastpass as an optional one?
Right.
Maybe to not put requirements on certain implementations, perhaps. I don't know.
And why is Mvpn called out? What about EVPN? What about other other applications besides Mvpn? It's just strange to see Mvpn called out.
Because that's what we've addressed in the draft. We can, if we should put in this draft EVPN and other solutions, we can certainly do that. But it's not one of our listed requirements.
I think maybe we just don't need to list it.
Well,
requirement
honestly,
at
as a
all.
requirements draft, and under the optional list, I'm not opposed to growing that list as the draft matures. But I agree, if just one of them stands there, it sounds like the rest don't matter. So if we're going to have an optional list of support, we should probably flesh it out a bit more.
Sure. Again, these are just the things that we've listed in the requirements draft. If we need to add additional requirements, we can certainly do that.
Jingrong, you had a question?
Yeah, I want to explain why Mpn is optional, because Tolly insists that BIER-v6 may be used for HomeNet. In that scenario, both Mpn and OAM may not be needed, so it's moved to optional.
Sure. The question wasn't why is Mvpn optional. The question is, if we're going to list Mvpn, why don't we have EVPN, other solutions with beer listed there, was all. So yeah, I understand why.
Mpn and Mpn are the same. Maybe it could be added to be parallel with Mpn. That's my comment. Thank you.
Okay, thank you. Mike, does it make sense for feedback in terms of fleshing
Yeah,
that?
Yeah.
Okay. Comments, questions, anyone else for Mike?
I have some comments from the member of the working group. I have read the document, and I think it's great to have discussions about the mandatory or optional requirements here. But I think at least the classification is valid and reasonable. And it is a good start to have the discussions in the mailing list about which exact item should be in mandatory or should be optional. I think all of that detailed discussions could be start based on this classification. At least this classification is clear and easy to move the work forward.
Thanks. Yeah, before we just had a whole list of a bunch of requirements, which was fine, but we felt that this may be more useful to steer the working group.
Yes, I think so.
Thanks. All right, let's go to the next slide unless there's more. Go ahead.
Another comment about support beer architecture. It's my understanding is that existing beer architecture is mainly based on their 2.5, as the doc mentioned, and now the layer 3 based approach, is that considered extending the architecture, or?
I will have some comprehensive comments at the very end about that. Yeah. Mm-hmm.
Yeah. Well, why don't you wait until the solution is being presented to discuss that?
It's a good call. Okay. Yeah, it'll be presented, and it's on the agenda here at the last, so we'll have a chance to dive in.
Okay, so again, our goal is to help steer the working group. If it's helped, great. We as authors feel maybe you should start considering some of these solutions as something that you may want to adopt. If it's not, then what's lacking. There's a few comments that's been made about the ordering of the mandatory and optional. We'll address those. If there's any others, then please let us know.
There's a question on the list about fragmentation and end fragmentation, and the concern that it won't operate as the draft actually explains. The fact that once you've chopped up the beer packet itself, it's not beer anymore. It's a fragmented V6 until the end of that segment, that fragmentation path. So, I think that needs to be addressed as well. So I just read it this morning. I think Sandy sent it out.
On the list?
Yeah.
Okay, yeah, it's 4:30 in the morning. I haven't seen it yet, so I'll take a look at that.
You want sympathy?
I do want sympathy. Gosh darn it, my eyes are still closed. So we do have a section on fragmentation, so I'll take a look and see what Sandy's saying, and we'll address it.
All right. Any other questions, concerns, comments?
Yeah, let Greg talk, and then I would like to kind of sum the whole thing up where we stand with this draft. I read it in excruciating detail. Greg, mic's yours.
I'm done.
Cute.
I just wanted to note, I think that OEM is always a must.
Okay.
Thank you.
Yeah, good feedback. Thanks.
All right, so let me sum that up. Please make sure you take minutes. So I'm happy about the mandatory and optional. And as to the view graphs, I like the differentiation you made between the 2.5 and the 3. And in no case, well, in the 2.5 case, this tunnel, if you want, is not a P to MP. Beer in 2.5 is not taking advantage of any kind of underlying multicast capabilities, because otherwise the ether encaps would also use L2 multicast, which we don't very consciously. Okay, so please make sure that you kill that in the draft because it's confusing. So the optional stuff. So I'm happy that the stuff is making it to the optional, right? I think we have a problem here with the charter. The optional stuff is suggesting that we should be basically building an L3 tunneling technology that is multicast capable. All right. Now, what does tunneling means, right? And why is the 2.5 stuff not tunneling? What is encapsulation and tunneling? What's the difference, right? Because I think we are fudging here. Tunneling normally preconditions a setup, right? It preconditions some kind of security, encryption, fragmentation. You care about all the stuff. Encapsulation does not. The whole beer architecture in our charter is 2.5. You fudged into the draft right now the tunneling, that the charter has something to do with tunneling. There is no word tunneling in the charter whatsoever. Okay. So you're asking to basically build a completely different layer with this optional stuff. It's fine. I mean, if that's what we agree on and we start to work on all the stuff, fine. But just be aware that you are stretching out the charter and building basically a completely new L3 tunneling technology for which we already have a lot of solutions. As to the native model, the OAM is also part of that, right? So now we have beer OAM. It's 2.5 OAM. If you start to build a V6 OAM into the whole thing, that you're basically generating a new tunneling technology with another OAM. Or you pick up the OAM of V6. There is no need, in my opinion, but and we definitely don't have the charter for it. But if we decide to stretch the charter there, but it's a charter discussion, right? To the native model, one little observation that struck me when I read the stuff and I observed the spring discussions about implications of security when you start to abuse V6 addresses as something else and put all these options on. Right now, it says that for deployment securing the native model, you need to have the beer packet in a trusted V6 domain, whatever that is, right? Because the V6 list did not even agree what is a trusted domain. At the same time, you try to push on the requirements that it's supposed to support inter-AS multicast deployment. Now, if you are talking about a closed V6 domain to even propose a security model at the same time you want to make this thing support inter-AS deployment, those two things seem to collide head on for me. And that's pretty much the end of my comments. So I hope the note takers caught some of the stuff. So I think this mandatory and optional has to be further clarified. And we have to talk whether we really want to build an L3 tunneling solution, which the optional stuff implies, whereas the mandatory section starts to look better and better. And the security stuff on the native concerns me to no end. So I would like to have very extensive discussion about the whole thing, unless we kill the inter-AS multicast deployment requirement, which is fine for me as well. Okay, I'm done. Thanks.
Thank you.
Let me add to that just brief. Oh, go ahead. We got someone in the queue.
No, we have queue. Please don't jump on the mic, all right? Because otherwise we'll have a holy mess. Torles was on the queue. Other people, please queue up and talk one after the next. Torles, mic is yours.
Thanks. Tony, was that as an individual contributor or was that a chair comment?
That was a chair comment. We have to steer stuff, right? And control the charter.
Yeah, I'm somewhat confused about this classification with the different type of ways that you describe tunnel versus encapsulation. So would there be a better way to formulate that into writing or so that can be discussed? Because
think very, very simply, Toles, in my opinion. Just replace wherever you have beer with MPLS, and think what will happen if you start to build for MPLS a V6 native solution. And think why MPLS has no fragmentation, no encryption, and so on. You can just replace beer with MPLS and go through the thinking. And MPLS is a very well understood and deployed technology. And if you try to build a V6 native solution, just think what would happen and start to insist on IPsec fragmentation and so on. That's my simple answer. I think that clarifies it completely.
Well,
Okay.
I think it would definitely be good if we take it back to the list to be able to give more thought on it than is possible in this limited time here. Because I currently can't get myself to think that the proposal is stretching the charter with the way it does things. So given how you're making that claim, I think it's important to see that we get more eyes onto your comments.
Yeah, no problem. So let me take that stuff to the list and let's discuss the stuff out, because I think we have a scope creep here, which, yeah, let's take it to the list. Yes, thanks.
So more questions in the queue?
I think the summary of two models is clear and easy to understand, and it can classify all the existing beer IPv6 solution, actually, I think. And also, I think both of the solutions or methods should be accepted by the working group. For example, the transport independent or native IPv6. I think from the charter or RFC of the architecture of beer, I cannot see why it should be excluded in this working group. And I think they are all reasonable from my side. So
they may be reasonable, but we're bound by the charter. Go look and search for tunneling in the charter.
Okay, I would say we're bound by need, and charter can be modified if we have to get there. What I haven't seen here is what value is being added. I mean, this comment, I did it in my comments in the email, and it's come back in this conversation quite a bit. We keep calling this native V6 solution. It's not. There's nothing about the beer forwarding that is V6. And even though you put the bits in an extension header, it's not V6. As soon as you get to that edge where you have to process now beer bits, V6 is gone. You're doing beer at this point. And so it's not clear to me how that V6 header gets reconstructed if you're doing non-BFR's midpoint. So again, there's problems with the solution. We'll talk about that at the end. But ultimately, I'm trying to understand what value is being added here, what additional functionality we're getting that we don't currently have with the myriad of tools already available to us across the IETF. So that's the challenge I keep trying to put forward. So I'm understanding what a unique problem you're trying to solve, because I feel like every time there's a descriptor and we pin it down with trying to understand it, the goalposts move and we go back and chase our tail again. So we need to focus the conversation and finish these things so we understand them and not just keep trying to bring it back around. So hopefully some of these conversations in the email will clarify. Maybe today's presentation will jar some brain cells loose for all of us.
Yeah, so that's the different way to structure the discussion. What problems are you solving and what benefit are you bringing, right? I'm being steered more from the technology differentiation in the charter. I'll take it up as lead on myself to start this thread on the list. Okay, Loa, mic is yours.
From a MPLS perspective, we had one working group in the MPLS working group that actually thought of any LSP, point-to-point or point-to-multipoint, as a tunnel. Was one time where we called RSVPT for RSVP tunnel extensions. We changed that. We made it traffic engineering in the end, but I think as soon as you have an LSP in your charter, you actually have something that is very close to or equivalent to a tunnel. Thank you.
Yeah, with respect to the points from Greg. I thought in the earlier discussion where I was sending replies to, I was pointing to one of the benefits being the way that the framing is handled, and that very often mapping into a framing lower than IPv6 encapsulation creates a lot of additional deployment challenges and implementation challenges. I mean, it may not be ideal for all the cases, but it's a very good baseline, right? And it also maps into the ability then to use, IPv6 filtering, IPv6 diagnostics as the lowest bottom frame and so on. So I think some of the questions, Greg, that you were asking were already raised or answered in the email threads and before. So maybe let's see if or what we can what we can do in the document that is missing in those explanations.
Well, we'll have it on the thread.
Yep.
Hello? Yeah.
Hello?
Everybody
Can you hear
please
me?
queue up and announce themselves. I'll be killing people just jumping the mic, okay? So Tolas, thank you. Sandy,
Hello?
yours.
Sandy,
Yes,
go ahead.
Sandy, yours, but queue up
Hello?
next.
Can you hear me?
Yes, I can hear you. Tony can.
Oh, okay. Oh, all right. Finally, I just sent some comments in the mailing list, and I think it must be solved before the requirements draft to move on. So please consider it carefully. Thank you.
Thanks, Sandy.
Excellent. Thanks, Andy. All right. Anyone else? We'll have more to discuss later with this as we go into one of the solutions. So let's move next. PFD and beer, which is Mirsky. No. Yeah, it is. Greg's coming back. All right. You ready, Greg? We don't see him. Did he fall asleep? There he is. All right. Excellent. All right, Greg, you're on.
Okay, so bring it on. Next slide, please. Okay, so we've been talking about how to practically and usefully apply BFD to beer network. And now we have two RFCs, 8562. It's demand mode with a head end, which is logically could be BFIR, that allows tails or BFIR to detect the failure of the multicast distribution tree. It's a standard track. 8563 details two methods for the head BFR to discover a failure of the multicast distribution tree for the set of BFR and notify the head end. Okay, next slide, please. So with the active tails defines three modes. The first mode, when in addition to periodically sending BFD control packets, the head end or BFR, I will use these terms interchangeably, sends poll messages. And poll messages are the same BFD control messages with a poll build set. And BFD base specification 5880 defines the poll sequence for the negotiation between entities between BFD systems of certain changes. And it will be configuration changes, or it could be to update of the status change. So the head end sends the poll message and expects the remote system to respond with their either poll if it doesn't agree, or with the final message. And 8563 active tail defines two modes. So they're multicast polling and composite polling. Composite polling is a combination of poll messages being sent over the multicast distribution tree and then sent individually to their BFR or to the tail, to particular tail, to the tail poll message, unicast poll message. So in that case, we can eliminate some false alarms, but detection time in this case will be the interval between polls. Next slide, please. So we can see here is what how it works. I use some other diagrams, so just excuse their labeling. So P1 in this case broadcasts their BFD control messages, and 4, 5, and 6 can detect the failure, but P1 would not know. So to know, for P1 to learn about their perception of 4, 5, and 6 of the multicast distribution tree is to send the polling messages. And if it sends over the same multicast tree, so it's a multicast polling. And if the multicast tree doesn't work, so their timer on polling message will expire, and it will send a number of polling messages to conclude that something doesn't work with their distribution tree. If 4 and 5 and 6 receive the polling message, they will respond to the poll with the final bit set individually. So P1 not only can learn of tails, but at the same time, it can learn of, okay, which one tail is missed to respond, so it can assume that there is a failure. And again, their detection time will be defined by the interval between the polling messages. Next slide, please. So it just illustrates how it will work. So, for example, if we have a failure on the segment between P1 and P2, so it will affect 4 and 5. So thus, multicast polling would not reach them. If we use a composite polling, so which is a combination of multicast polling and unicast polling, and unicast polling suggested not to use multicast distribution tree underlay, so the detection will be faster. But again, the important part here is that the failure detection is determined by the interval of the polling, and usually polling interval is longer than interval between sending BFD control messages. Next slide.
Can I throw a question in here? You said the tree underlay. So I'm in terminologies I'm getting mixed up in, because I don't think of beer as being a tree at all. We've got a replicating fabric, and I define ad hoc tree forwarding based on the header of the package itself. So ultimately, that underlay is taking the shortest path based on unicast forwarding, or unicast routing, effectively, right? And it builds that. So if I'm sending a unicast poll, it's taking the same path.
True. So again, there is a challenge. Yes, I agree. Again, for example, for a composite polling to be useful, there needs to be certain support to make a disjoint of unicast poll being sent the path and from the multicast tree that we're monitoring.
Oh yeah, well,
it might. Yeah, I agree. That's a big. Well, that's a sort of the elephant in the room. Yes,
right. That's a tough requirement. I mean, I could see deployments doing something like this, but it kind of really complicates the network.
I understand. Yeah, I agree. Again, you know, the first of requirement of OAM is that especially active OEM, is that our probes, our test messages are in band with the data flow.
Yeah.
But at the same time, especially here in this example, we want to have a guaranteed disjoint paths. Because effectively, this composite polling, the unicast poll messages, are sort of out of band.
Yeah. All right, we've probably just flushed it out a little bit of description in the draft because, I mean, one of the clear benefits of beer is simplification. The fact that we don't have any other really routing functions at all, that beer is just a forwarding model, that we rely on the underlying unicast infrastructure that's already in place, and beer just rides on top of it. So requiring another layer, I mean, let's just flesh that out, make sure we understand the complexity required here.
Okay.
It's not just
Yeah, but again, my understanding is that there the network that we are sending the beer over might not necessarily be best route, but it could be, for example, path engineered.
Could be, right.
Yeah, right. So I agree with Greg, the S1. Greg, I think you need to flesh that one out and think also through, for example, architecture where there will be no IGP at all, but all the beer tables will be controller programmed. So I think you may need an option where the unicast poll goes either in band or out of band from my side. Jeffrey's on the mic.
So I haven't read the updated draft recently. I read the draft when it first came out before. I still have a question on why is beer involved in this? What all these polls and answers, all those mechanisms, does it not apply to say R3PT, P10P tunnel the same way? It seems to me that the beer here is really just a means for you to gather those messages through. It does not need any to beer to be involved at all. And also, what do you do after you detect the failures, things like that? It does not seem to be beer specific either.
Okay, I agree. It's not beer specific. It's specific for multicast distribution tree. But let's proceed because I think that to this point we already presented and discussed. So now we're getting to another mode, which is just barely mentioned in 8563, and it's head notification without polling, unsolicited event triggered.
As a quick footnote, it is beer specific because the packets are all carried in the beer OEM frame, as they should.
Okay, thank you. Okay, so as noted, there are three modes being mentioned in active tail BFD for the multi-point networks. And the third one is not technically detailed and discussed, but I think that's the most interesting for beer because it doesn't use the polling messages. So instead, their BFER, which is a tail in the distribution tree, is sending its own poll message to the head end when it detects the failure of the multicast distribution tree, informing the BFR of the failure. So that significantly improves their defect detection time. So what happens then, it's again, it's up to the protection scheme that is used in this particular beer domain. It could be that BFR changes something in how it sends their packets. or it might be being indicated to their controller to change the distribution. But let's go. So this is next slide, please. Right. So this is diagram just to indicate how it works. When there failure on a network on a distribution tree occurs, there is no need for P1 to pull tails. P4 and P5 will detect the failure and detect the failure in terms of a regular BFD, so missing and consecutive control packets, and then will generate unicast poll messages addressed to P1. And everything works because we can map ID to IP address, so they can do it out of band. And P1 will send them unicast final, so they will stop sending these periodic poll messages. What happens after that? It's outside of BFD. So whatever protection mechanism is used, recovery, restoration for the control plane or otherwise, it's not part of BFD. But the BFD part is only the failure detection. Next slide, please. So welcome discussion, and I appreciate their working group adoption call. So looking forward for your comments and questions.
So let's see, there's a hum thing here, right? How do we hum this? Is that it?
You just start a hum. So what are we humming?
Look at that. All right, who's read the draft?
I did, but I'm not allowed to hum.
Me either. It says right there, my role does not allow me to hum. We have no readers.
No,
I
you have to
read.
wait. Yeah, you know, this training session was actually not half bad.
To teach you how to hum?
Repeatedly.
I'm not
All
going
right.
there.
Yeah, so no.
So we got a couple of readers. Who thinks this is ready for adoption? All right, we need activity on the list then, Greg. I mean, we have people that haven't even read this thing yet. I think there's some outstanding questions on it anyway. It's work we should definitely be monitoring within the group. We'll see if we can make progress, and we'll call for an adoption later if people get some traction. As I think this work progresses regardless. So anyone else want to chime in? Listen for hums? Wow. Is it everyone asleep?
No, it runs.
We're at 0. All right.
Okay, so not much either, whatever that means. Okay. So what, discussion on the list?
Yep. Back to the list of some of these comments.
I mean, one question I would ask everyone, what's the alternative? Right, I don't see an alternative. This is a pretty clean OAM BFT solution right into beer.
Yeah.
We'll need some kind of OAM, you know, failure detection on the trees. What will we do otherwise?
Well, I think, I mean, I'm not going to suggest throwing out the complexity of waiting for a second path to return. I mean, that's fine if someone wants to deploy something to that scale.
Yeah.
But I think it'd be great to have describe the use case in which there isn't a unique path, that this is just a replicating fabric. I mean, how do I do that detection without having to build a parallel network?
Right, and people who build a parallel network, right, or partition the network, they run live protection anyway, which is completely disjoint, which is its own, you know, kettle of fish. Yep. Right. So Jeffrey on the mic.
So, Tony, you mentioned earlier that the data are sent as beer OAM packets. I still don't see why it needs to be beer OAM packets. It seems to me that for whatever you need to do here, for your purpose, if you just send them as regular BFD packets, like however you do with Ethernet or with MPLS.
Well, wait. The problem is that this is multi-hop, right? So you don't know whether it will be in-band. That's the first problem. If you go BFD monitor basically on a parallel path to the underlying carrier, that is pretty much worthless. The second one, so the second observation, disjoint yourself from the thinking that beer preconditions IP. Beer is a replicating fabric, and the IGP signaling is somewhere circumstantial. It was the simplest first solution, but you could run beer without any IP whatsoever in the network. So how will you encaps BFD then?
BFD.
Yeah.
Well, so how does beer or MLDP work? It's the same. That's the same question, right?
MLDP is completely IP specific, and BFD today runs on UDP. But if we have beer, pure beer, it's just a fabric. Don't forget, IP is circumstantial, fully intentional. So we have to provide an OAM which works without IP, if we do our job well.
Well,
so
I see that the some of the messages are addressed to the DFIR IP addresses.
No.
No, they're not. Read the draft.
They don't have to be addressed. So for the multicast, for the multi-point networks, it uses not a synchronous message, but a demand message. And demand message is explicitly unidirectional. So thus, you don't have to address it to the particular IP address.
Right.
I was talking about the return packets.
The return packets are unicast.
Yeah.
Yes.
And that was my observation. Think about it. It has to be optional, so you can run without any IP whatsoever. If you find an IP address which is used to route the BFD message, then the solution doesn't work properly in OAM, in beer OAM architecture. So it's an interesting draft, right? And we use BFD messages, of course. Why should we reinvent BFD, right? But this is, in a sense, circumstantial. BFD just provides, the failure detection. But all the encaps should be OAM beer.
You can get it from the later presentation of beer source protection. We will discuss the situation which use the beer BFD.
Great, thanks, Andy.
Thanks, Andy.
Okay.
Any other questions on this draft? Looks like there's a lot to discuss on the list. Ready? Thanks, Greg.
Okay, thank you.
All right, looking forward to this. All right, Daniel, you're on.
Hi, I hope you can hear me now.
I can.
Great. Okay. So I'm just going to introduce myself. I'm Daniel. I'm a PhD student at the Chair of Communication Networks in Tübingen. And Professor Ment requested this slot so that I can present some research insights from beer and P4. And there is a video version of this presentation with more details. If you're interested in it, I can send you the link. In the video, I prepared a quick introduction to Ip Multicast and beer. I don't think that this is necessary right now, so I think we can skip the first few slides. And exactly. Yeah, skip. Okay,
Which one?
Skip.
2, 3.
And the next one should be interesting, I think. Yeah,
right here?
Exactly.
Okay.
I want to start.
Don't rush, Daniel. This is a very good prezo. Take the time you need. It's very interesting.
Sorry?
Stuff. Thanks. Don't rush. Take your time. This is a very interesting prezo. to
Okay,
please
yeah.
walk us through it.
And if you have any questions, just ask me. I have a coworker here in this Meetecho room who has a lot more knowledge about P4, who did the actual implementation. And yeah, just ask the questions. Okay, so just a quick intro to P4, because this is the relevant technology in this presentation. P4 is a high-level programming language to describe data planes, and the target-specific compilers then map these programs onto the programmable pipelines of the targets. P4 programs are written for different architectures, and the picture shows the PSA, which is the portable switch architecture. It's the reference architecture. Others have different properties, but now I'm going to talk about the most important things. So no, that's fine. The slide was fine.
Oh, sorry.
No problem. The pipeline is separated in an Ingress and Egress pipeline, and both consists of parsers, deparsers, and a match action pipeline. The parsers are programmable, so you can like deploy custom headers with P4, which is great for implementing novel protocols. And the programmable match action pipeline is just some kind of control flow with if statements and different match action tables to execute packet-specific actions like finding the next hop and so on. And another important part is the packet recirculation, which is actually not P4 specific, but this is important for our implementation. So I'm going to explain it in detail. So now, next slide, please. Yeah, thank you. If you want to recirculate a packet in P4, you have to send it to a specific switch intern recirculation port. And after the packet has been processed by the Ingress and Egress pipeline, the packet is then not sent through a physical port, but to this switch intern port, which then processes the packet like it has been received regularly, so from the beginning of the pipeline. The problem is that this port has only limited capacity, and if too many packets are recirculated or too often, then this port is overloaded and the throughput may decrease. And you can increase this, we call it recirculation capacity, with additional physical ports in loopback mode. So when a packet should be recirculated, you send it either to the switch intern recirculation port or to one of the loopback ports. We implemented some sort of round-robin approach to distribute the load on the ports and use this in our BIER implementation. Okay, next slide, please. Yeah, what we basically did was to implement the BIER header in P4. The basic idea is that from this BIER header of a packet and some paths, maybe from the IGP or a controller, we determine, or a switch determines all of the next hops, creates the right amount of clones, and then forwards the packets to all of the clones to all of the next hops. The problem is that this cannot be done in one pipeline iteration, at least not with some major downsides. So we implemented a forwarding scheme over multiple pipeline iterations. And first, I'm going to talk about what happens to a BIER packet in one iteration. First, when the BIER packet is received by the switch, it processes the packet in the Ingress pipeline, which basically finds the first next hop and calls a clone operation. However, the cloning is performed only after the Ingress pipeline. So after the Ingress pipeline, one packet instance is forwarded to the determined next hop, and the clone is then processed again in the Egress, some changes to the header and stuff, and then sent to a recirculation port so that it can be processed again. Next slide, please.
Just a question on this. So that packet that's going top blue there, that's first bit set, correct?
Sorry, the first?
It's just like first bit set. You're going through the mask, right? You see
exactly.
the first bit set. Okay. So you're doing a first bit set and then walking the header from there. Each replication is another bit set.
Yeah.
How are you clearing those bits of those if they're all parallelized at this point? Right. You got to know who's been forwarded and cleared. I guess you're only clearing the bits on that packet. So in this blue path, the bit clearing is taking place in this BIER process here.
Yeah. So this is really P4 specific. It has some special properties about cloning and stuff and metadata. And if you want to know the technical details, which maybe a lot, Steffen can tell you about it. But so basically, we store the FBM from the BIF in a metadata field, and then in the egress, so in the ingress, basically, we change the packet header to the bit string that is sent to the first next hop. And in a metadata field, which is some kind of variable, we store the information of the remaining bits and set it to back into the header of the packet clone in the egress pipeline.
Okay. So this is a combination of P4 and, of course, the architecture that you're putting this onto that doesn't have any replication mechanisms in the fabric. It's just a recirc pipe.
Yeah.
Right. Okay. I'm just wondering. I'm just trying to get my head around what's possible here. Assuming we had some more robust hardware that had replication in the fabric, this pipeline wouldn't be a limitation of P4. That's just an architecture limitation.
Yeah. So actually, there are some limitations of P4 that require some workarounds.
Okay.
The whole thing also depends on how many packet descriptors your silicon can carry, and from where on you have to recirculate. It's a little bit silicon specific. So assuming something like everything is every copy is a recirculation is the simplest model.
Yeah.
Toles was on the mic. Daniel was on the mic. In sequence, please. Toles.
Yeah, no, and I'm thinking that maybe we get through the slides first before getting to these things of the hardware, because I think there would be more to be said about it.
Daniel?
I don't care. But yeah, I can continue. So next slide, please.
All right.
As I said, this is basically what we just talked about. This is an example where a beer packet, should be sent to 3 neighbors at 3 next hops. So when it arrives at the switch, one packet instance is forwarded to the first neighbor, a packet copy is recirculated, and in the second pipeline iteration, it's the same. One instance is forwarded to the next hop, one instance is recirculated, and in the last iteration, the last next hop receives the packet and processing stops. And here 2 things are important. The first next hop always receives a packet before the packet is recirculated. This is important for the throughput evaluations later. And a packet with n next hops has to be recirculated n-1 times. Okay, next slide, please.
Right. This answers a question I had. It appeared as if the replication was happening and each of these circs was in parallel, but they're not. They're all serialized. So
yes,
that way
exactly.
It's all retained. Okay, makes sense.
Yeah,
thanks.
There is a way to do it in parallel. However, then no dynamic kind of configuration is possible, and you would have again some dependent state of the BFERs of the subscribers. There is a lot to discuss actually about it. We had some different approaches to implement it with different advantages and disadvantages.
Oh, good.
But this is the most simple one.
Okay, excellent. Thanks.
Yeah, as I said before, this packet recirculation may have a negative impact on the throughput. So we thought about measuring it, and we built a little setup. This is the logical setup, very simple, with a source that sends IPMC packets to a BFIR, which encapsulates the IPMC packets and sends them to the BFR. And the BFR then sends the packet to a number of BFERs. And we always measure the throughput at the last next hop, because it is affected the most if the recirculation ports are congested. We built this logical setup then in hardware. So next slide, please. Yeah. With the Tofino as a centerpiece, the Tofino is a P4 programmable high-performance switch ASIC. It is used in the EdgeCore Wedge 100 BF32X, which is then in fact a P4 programmable 100G switch with 32 100G ports. And we deployed our program on it. We have a traffic generator with up to 100 gigabit per second that acts as an IPMC source. It sends the traffic to the Tofino, which encapsulates the packets and then sends them to a number of next hops, which are BMV2s. BMV2s are P4 software switches, but since we want to measure the throughput in hardware, we send only n-1 packets to the BMV2s, and the last next hop is always the traffic generator itself, so that we can measure the throughput in the end at the traffic generator. The Tofino is connected to a controller which configures the whole setup. And if you go to the next slide, I can show you the
Can I ask what
results.
your Encap was?
Sorry?
Did you actually implement the beer ether type for the hop by hop transfer?
Well, not that. We did the Encap, but it was more like if a multicast packet arrived, we put a beer header on it.
Sure. Yeah. Right. Okay. Right.
So just prototyping for the setup.
Clear.
But
Thanks.
doing it would be not that hard actually.
Probably hardware dependent. You have to have the support in the framer, which a lot of this.
Well, yeah, but I mean, in P4 you can like match on anything. You can build your own headers. Or what do you mean exactly?
The actual outer header, the hop by hop link local framing, right? That's ether type.
Yeah. We implemented that.
Okay. Wow. Excellent. We have a question.
Wim on the mic.
It was a video request.
Wim?
Video? No, I think it's do you hear me?
Yep.
I hear you now. Yep.
Yeah. Did you also measure the latency incurred with every recirculation? Did you also measure the latency addition?
These are details Steffen have to talk about. I think we did it. But yeah, he is writing Q, so he can tell you about it.
Okay.
Excellent.
Steffen, you want?
Okay. So basically, it roughly depends on the complexity of the data plane, but you can say one pipeline iteration requires about 300 to 400 nanoseconds, and that's the added latency that you get for each recirculation.
Wow. That's
nano,
tight.
you said, right? 300 nano?
Yeah.
Right. Okay.
That's a mild wow. Yeah. Mm-hmm. Yeah.
Wow.
Yeah, so the basic idea is that everything that compiles to the Tofino is running in line rate. Of course, if you have like 3 pipeline iterations because of recirculation, you have the additional latency of the additional iterations.
Right.
Okay.
Excellent. Thanks. We have another mic.
Gian, you have the mic. Go. Okay, next one.
Okay, great. So basically these are some measurements we did. The traffic generator sends with 100 gigabit per second, and on the x-axis we have different numbers of recirculation ports. In the first one, we only have the switch intern one, and we see that this is enough to forward the traffic to 2 next hops in line rate. And if the number of next hops increases, of course, the throughput decreases significantly because the port is overloaded. And if we increase the number of recirculation ports that are available, then we can sustain a higher number of next hops. So this may look a little bit bad in scalability terms, but we're sending with 100G. If we assume like a smaller fraction of multicast traffic in the network, we get other values. And then the interesting question is, how many recirculation ports do we need to prevent throughput decrease? And this is what we also thought about. If you go to the next slide.
Just a question. When you say recirculation ports, you're talking about internal to the forwarding chip, right?
So there is one switch intern recirculation port. And if you need more to prevent packet loss, you need physical ports in loopback mode. When we talk about recirculation ports, basically we mean that we always use the switch intern one. And if this is not sufficient, we deploy additional physical ports in loopback mode. So in this figure, the left column where number of recirculation ports is 1, we use only the switch intern one. And in the column in the middle, we use the switch intern one and one physical port in loopback mode.
Okay. Does that take that physical port off of capacity of the switch?
Yes.
Okay.
Yeah, so that was my observation about the architecture. Basically, how many packet descriptors with the metadata can you carry through your silicon, right? So there are of course other chips that do different trade-offs, and the more beer-centric the chip will be, the less it will be doing the recirculation, and the more basically replication just of packet descriptors would allow. But you know, nothing's for free, especially when you bake sand.
Yeah, if you go to the next slide.
So let me just comment here. Ultimately, this is a replication problem and not a beer problem.
Yes. So it is actually a problem of the features provided by by P4. Sorry. We had an approach where we could implement beer. We think that we could implement it in line rate for any numbers of neighbors and whatever, but it would require like exponential state independence of the number of next hop, which is, well, not that good. But yes, it's a problem which features are available.
That in itself would be a very interesting presentation maybe for next time.
Yeah.
We can discuss it.
Yeah, absolutely. Yes.
And as next hops, just to be clear, this is not endpoints. This is just neighbors.
Yes, exactly.
Okay. Excellent.
Yeah.
Right.
This slide is there we. On this slide, we try to calculate how many of the physical ports are required to sustain the throughput.
Yeah, I think this is a very valuable discussion, since beer is moving more and more to implementation. That will give silicon designers and people deploying and judging different solutions kind of a handle. What you have to pay for what kind of beer quality. So
yeah.
I think that the discussion around, you can have it linear, but that's the amount of state and silicon for the next time, would be excellent, right? Outlining the solution space. Edward on the mic, your mic.
Do you hear me?
Yes.
Yep.
Okay. I have a question about bitstream size, because every ASIC has a restriction about how large could be headers to process, and the bitstream could be huge. Bitstream could be half a kilobit, for example. It's easy because it could be 500 routers in the network. For that reason, did you have any test for Tofino for how long could be the header, how long could be bitstream which is supported by this particular ASIC?
I think in the prototype, so this would also be a question for Steffen. In the prototype, I think we used 128 bits for the bit string in the beer header with the additional fields. In the end, I think this has to be answered by Steffen, and we have to consider that we signed an NDA with Barefoot, so I'm not sure about what details we can talk. But from what I got is, so Barefoot is the manufacturer of the Tofino. And from what I got, since they that they are trying to remove the NDA to talk about the more interesting stuff. But Steffen, if you're available,
Okay. Thanks, Edward. Toles, mic is yours.
Right. So I think we're at the end of the main section. Afterwards comes the BRFR. So I think one of the interesting follow-up points would be to recognize that there is this basic challenge of I think the current hardware is it's to only be able to have preordained replication masks to actually do native replication in the fabric, right? As opposed to what beer would require, which is to calculate the replication mask or else lose the throughputs through the recirculation. So maybe one thing would be to come to figure out a proposed P4 extension abstraction, go to P4 forum and say, here's basically, a programmable replication mask abstraction so that future fabrics could implement something so that we could really calculate the replication bit mask and not have to reuse circulation, right? So that was my thinking on the topic.
That is actually fairly clever. If you have a controller, you could actually take advantage of that because you see a whole network And instead of sending it along shortest path, you could actually use this pre-computed mask to not load the silicon. Yeah.
No, I was actually just thinking about you have the P4 program, and instead of doing, on every recirculation a calculation of here's the next bit I'm doing, you're doing upfront a calculation of the FBM, and then you're sending the packet with the FBM. What would be the right P4 abstraction to do it? Whether or not a particular hardware can support it is secondary, right? But use the P4 language as the model to define here is at least what we need to do a native beer without recirculation.
Yeah. This is something we're already talking about. We did some stuff with P4. Currently, we are writing a P4 survey, and we found some limitations that are pretty common during on a lot of works with P4. And this is also something that you cannot dynamically clone packets to the egress ports.
Right, and I think there is a P4 forum, so I think the question is figuring out how to make a proposal for a language extension to use that forum to talk effectively with the hardware vendors.
Yeah.
Okay.
Stefan, do you want to answer the question with the bit string?
Stefan, mic's yours.
So as you said, we implemented it with 128 bits. I don't have exact numbers, but there is basically not a very hard limitation on the header length. So 256 or even 512 should be no problem. Yeah.
Great. All right.
Yeah. So in this prototype, in addition to regular beer forwarding, we wanted to do some resilience stuff. The beer patent mentions some kind of fast reroute based on loop-free alternates. In previous research, we have found that the loop-free alternates they have some downsides. They cannot protect against all single link failures. They may cause some micro loops. And so we thought about a very simple protection scheme for our implementation, which we call tunnel-based beer fast reroute. If you go to the next slide. Sorry, that the slides are like split. Yeah, well, the basic idea for us was that we tunnel the packet through the routing underlay because we thought maybe some kind of unicast mechanism is deployed, or sorry, the forwarding entries of the routing underlay are computed faster, so the packet is tunneled around the failure. But more interesting, I guess, if you go to the next slide, is how fast we can restore connectivity in the event of a failure to switch from a primary path to a backup path. And we built a similar hardware setup as before, where the Tofino sends the packets on a primary path. Then we switch this path off and measure at the destination how much time it takes until the packets arrive again. So if you, again, this is done with the Tofino, and which is important to mention that the controller is directly connected to the Tofino, which means that communication is very fast. If you go to the next slide, please.
Do we have a question in the queue?
Oh, yeah.
Should we take the queue? Okay. Greg, mic yours.
Yes. So it's very interesting. Thank you. What triggers the switchover?
I think this is there is some NDA restriction to talk about it because this is highly Tofino specific.
Okay. So basically, you don't have the OEM protocol detecting the failure. You trigger something internally just to measure the switchover.
Yes, it's done. So it's switch target specific. So the Tofino does not implement the PSA, the portable switch architecture, but it has its own architecture, which is very similar to the PSA, but there are some target specific features. And one of them we use to detect the port up down events, you can say, and then we switch back to the backup.
Okay, so effectively you look only at your local port. You don't look in a beer domain failure.
No, it's local fast reroute. So, I mean, you could do it with some kind of liveness detection to remote points in a domain where maybe some non-beer devices are in between. The mechanism would basically on data plane would be the same.
I see. Okay, thank you.
Yeah, what we see on the left is the reconfiguration. If no fast reroute mechanisms are deployed, then we require around 166 milliseconds. Remember at this point that the controller is directly connected to the Tofino. If this would not be the case, the restoration time would have been significantly higher. And basically on the right side, we see the restoration time for the fast reroute mechanisms, which is about half a millisecond. So the switchover is pretty fast. Yeah, that's basically it. If you go to the next slide, there is a short conclusion, but I mean, it's basically beer in P4 on 100G hardware and fast failover. That's basically it. Yes.
I mean, not to nitpick too much, but this is specifically Tofino performance. This is not necessarily just P4 itself.
No, this is, of course, this is Tofino because we deployed it on Tofino, on the Tofino hardware. Yeah.
Right.
So if you use
going back to the replication issue, I like Torles's idea. I mean, I was kind of thinking around the same ideas, like what feedback can we make to the P4 forum to understand, what the gaps are. But what's happening in just IP multicast? I mean, this is, again, at the core, it's a replication problem in the hardware that takes up those ports. Is there specific P4 replication semantics that are used for multicast that we're not using for beer, or is there something we can use? But Torles's idea, if beer can facilitate that replication better in the hardware because we can pre-compute, that would be, a fascinating point of progress as well.
Yes,
maybe I can answer the question directly. So there is a native multicast feature, or let's say in the P4 language, there's multicast defined, and the Tofino has a native multicast feature, but you have to define multicast groups a priori, or let's say you have to define them via the control plane. So if our distribution tree changes, we would need to change the multicast groups definition for the beer header. And of course, we would have first a dynamic state and exponential state if we would do it without dynamic, and that's just not feasible for this solution.
So I think this is fairly common to all ASIC-based forwarding, right? I think P4 simply adopted what they've seen in enterprise and data center switches, right? So you basically got a lookup table of however many entries you can have, 100, 1,000, 10,000. Each entry has a replication set. And then basically your whole forwarding table is, lookup S, G, star, G, replicate to entry number 1, number 100 or so. So that's basically the state that you need to establish. And in our case, it would be 2 by the power of n possible output interfaces. That's the exponential stuff. So this is the old hardware for IP multicast that's not ideal for beer. So and that's basically the discussion to have with P4, how at least in the language abstraction we could overcome that, have a native beer semantic, and then see what switch vendors can make out of that.
Yep. All right.
Yeah. So you're addressing a very important issue with that. I mean, in P4, there has been a lot of P4 research in the past years. In the last year, a lot of work has been published. So we hope that the vendors or the manufacturers are listening to the community or to the researchers or to the industry, whatever, about missing features. And I mean, that would be great if something like that could be implemented.
Excellent.
Yeah, great, Prezo. I think it's an excellent idea to bring it to the P4 the forum and push it there. Looking forward to more presentations. The protection stuff is not entirely to me whether you can use TILFA for that stuff, whether it is TILFA or a parallel thing. But I mean, the number is interesting, of course, albeit not too surprising. Thanks.
So you said you had a demo video too. I don't think we're gonna have time, but let's see if maybe we can throw it at the end. Otherwise, put it on the list and we can all watch it there.
Yeah, so this is not a particular demo. It's a video of this presentation with a little bit more details. But yeah, I will post the link on your list so that you can watch it again if you want to. And actually, we are currently a paper about this beer implementation is currently under review for the for a TNSM special issue, and maybe this is also interesting for someone because there are more other results and more details about the implementation.
Excellent. Thanks for this. This is great.
Yeah, thanks.
Comments, questions? We're getting a little wedge. We've got 3 presentations left, so I think we should move along.
Yeah, thank you.
Thank you very much. This is great. Next up, we have Xiaomin. Oh, we got him. Got him, Tony? I got him. All right, can we hear you?
Xiaomin. Did we lose the room?
No, I'm still, yeah. See Xiaomin, but I don't hear anything.
Yeah, and your preso also went away.
My preso went away? This is gone?
Yeah, I don't see that. Did I push something? No, I don't think so. That's all right. Xiaomin, you there?
I should be sharing screen still.
Not that I see it.
Oh, look
Now.
at that. All right, just now I do. Is it back?
Coming,
So-
something coming. It's you probably have to allow sharing. It shows 0 kilobit.
Do we make it okay?
Yes, you're good now. All right, here we go.
Okay. Hello, everyone. It's Xiaomi here. This presentation is on beer encapsulation for IOM data. This is a 00 version draft. Next slide, please. This draft provides the encapsulation for IOM over beer. 2 options of encapsulation are described and compared. Option 1 is beer header plus beer OEM header plus IOM header plus payload. Option 2 is beer header plus IOM header plus payload. In this draft, option 2 is selected as the standardized one. Next slide, please. This draft outlines requirements on IOM over beer. Some multicast flows are sensitive for loss, delay, and other factors, such as live video, real-time meeting. The operator wants to know the real-time statistics for these flows. Then in-situ OEM is an applicable OEM tool to fulfill the requirements. It provides a way to achieve on-pass telemetry information collection. Next slide, please. Here is the encapsulation format of option 1. Outermost header is the beer header defined in RFC 8296. Then below beer header, there is beer OEM header, which is defined in Mpn working group draft. Then below beer OEM header is the IOM header. It contains IOM type, IOM header length, reserved field, and the IOM data defined in IOM data working group draft. Then below IOM header is the payload of data packets. Option 1 requests to assign a new beer OEM message type for IOM, but doesn't request to assign a new protocol type, because the OEM message length can be used to decide the border between the IOM header and the payload. Next slide, please. Here is the capsulation format of option 2. The outermost header is the beer header defined in RFC 8296. Then immediately following the beer OEM header is the IOM header. It contains IOM type, IOM header length, reserved field, next protocol, and the IOM data defined in IOM data draft. Within them, the next protocol field follows the definition of beer proto, including the new value TBD, indicating next IOM header. Then below IOM header is the payload of data packets. Option 2 requests to assign a new beer protocol type for IOM. Next slide, please. Here are some considerations on why encapsulation option 2 is selected as the standardized IOM over beer encapsulation, and the relationship between beer PM and beer IOM. We think option 1 and option 2 both are feasible for IOM over beer encapsulation, and option 2 is selected in this document. The first reason is that option 2 is more concise than option 1. Option 2 doesn't need to encapsulate beer OAM header, but option 1 needs to. And the second reason is that option 2 is a relatively common method for IOM over foo, such as IOM over GRE and IOM over NSH. All of them use a new protocol type to indicate IOM header. For beer PM, there are 2 OM bits within beer header, which are defined as beer PM marking bits. Using the 2 OM bits is orthogonal to carry IOM data. Next slide, please. Next steps for this draft is to revise it based on received comments, and then ask for working group adoption. Thank you.
No one on the mic. So then 2 questions from my side. Well, 1 observation. So I think we have 6 bits for the beer protocol. So I, just as participant, I see no problem to add, a different protocol. My only question would be, we have the 2 bits, right? The marking bits. Will you also assign different semantics to those bits based on the protocol, or the bits remain in terms of semantics?
No new semantics. It remains.
Okay. Right. So I mean, it's an optimization, but I see nothing wrong with it. Thanks.
Thank you.
Thank you. So who's read the draft?
I read it.
Read it. We're supposed to hum. Is that what it's looking for? Looking for sounds? But if you're on the mic,
Yeah, hum. We have the tool. Humming's official now. We don't have hands.
Wow.
We are only talking heads now, but only if everyone has video.
Got it. All right. Who's read the draft?
Yep, I did.
We got 2 people. I'm not confident in this tool here, Tony. I mean, normally I look up and see people avoiding eye contact, look at the keyboard. Clearly, they're not going to vote. But
yeah, the algorithm will not be disclosed. Probably depends how hard they push the button.
So let's get that thread on the list. Let's see if we can get some traction there. I think even for myself, better understanding IO AM and trying to get my head around what we're adding here, but it makes a lot of sense. Anyone else? Comments, questions? All right. Thank you very much. Moving on. Beer source protection. Sandy, you ready? There we go.
Sandy, mic is yours.
Sandy? Can anyone hear me?
Hello? Hello? Can you hear me?
There you go. Okay, I hear you, Sandy.
Okay. But that seems like there are no enough time to present it, but I will try. Okay, let me start. Hello, everyone. This is the beer source protection chapter. We have co-author Greg Chen Yisong from China Mobile. Next, please. We know that beer can use the IGP FRR function to achieve fast convergence. That is, if the path between BFIR and BFER fails, the BFIR can still send the packet to BFER as long as there is another working path. This document is talking about that there is no another path. So The failing BFIR cannot send the packet to the BFER. Let's see the background of this draft. As we all know, multicast source connects two routers to avoid single node failure. In this figure, there are two ingress routers connected to a source. In beer domain, the two ingress routers are called BFIR. This document tries to discuss how to reduce the packet during the BFIR switchover. Somebody may be confused by the name of the draft. We don't talk about the protection between multicast source and the BFIR because there are many ways have been defined to do it. We just talk about the BFIR switch over perspective. Let's back to the slides. The two BFIRs advertise the multicast flow information from source to all the BFERs through beer overlay protocol. BFER learns that the multicast flow can be got from BFIR1 and BFIR2. So for BFER, BFIR1 and BFIR2 are both upstream multicast hop candidates. For a specific multicast flow, BFIR acts either as the selected BFIR or backup BFIR. The selected BFIR forwards the flow to BFER in response to the request from BFER. The backup BFIR is in the standby mode for that flow. Next page, please. The follow standby mode detailed description has not been finished in this draft, but today let's discuss it. In Mvpn failover drafts, 3 standby modes have been introduced. Cold, warm, or hot standby. For cold standby mode, the BFER selects BFIR, for example, BFIR1 as the UMH and signals to H to get the multicast flow. When BFER finds that the BFIR1 is done, BFER signals to BFIR2 to get the multicast flow. For warm standby mode, the BFER signals to both BFIR1 and BFIR2. In case BFIR1 is the selected BFIR, BFIR1 forwards the flow to the BFER. The backup BFIR, for example, the BFIR2, must not forward the flow to the BFER until the selected BFIR is done. For hot standby mode, the BFER signals to both BFIRs. Both BFIRs are sending the flow to the BFER. The BFER must discard the duplicate flow. In this situation, there are no selected or backup rows in BFIRs. Next, please.
Just a question. How deep do they go to detect the duplication?
He must select the right BFIR, which is according to the BFIR ID in the beer header.
Yeah, so the problem is very real, and this is useful, but mostly people who run this kind of live, they want completely disjoint topology. So how do we make sure that there isn't an BFR something in the middle, which is in both paths? At which point in time, basically, doesn't matter which BFIR you select. If this thing fails, you lose both.
But that's a network engineering problem. I mean, if I'm doing live, I've engineered my network around it with rings or something like that.
Yeah,
right?
but I mean, if you provide something like that in beer as a technology and you're not addressing the problem,
Beer's forwarding. You can do that in the underlay and create 2 beer fabrics, but beer itself is just forwarding.
Okay.
Right. I mean, if it's something we need to put in there. So I was thinking, clearly the question I had was at detection. If we're doing at the BFIR, that's quick, right? We don't have to decap the packet and go into the data somewhere and look at a sequence number or something like that. That's clean. So then each BFER in this live scenario detects its primary. I mean, then all those live mechanisms will be there, like when the hysteresis in a queue. All right. Thanks.
Thank you.
Next slide.
Next, yeah.
Okay.
So this is a comparison among the 3 standby functions. For BFIR, in cold standby mode, just do the regular operation, forwarding flow according to the request from BFER. In warm standby mode, the BFIR should take the role of selected BFIR or backup BFIR or neither of them. the backup BFIR must not forward the flow to the BFER. When the selected BFIR fails or the path between selected BFIR and BFER fails, the backup BFIR must start forwarding the flow to BFER. In hot standby mode, the BFIR need not to know the roles of selected or backup BFIR. BFIR just forwarding the flow according to the request received from BFER. For BFER in cold standby mode, the BFER must select BFIR as the selected BFIR and signal to it. When the selected BFIR fails or the path between the selected BFIR and the BFER fails, the BFER must signal to the backup BFIR to get the flow. In warm standby mode, the BFER does not select the selected BFIR or backup BFIR. The BFER just signal to both of them. In hot standby mode, the BFER signal to both of the BFIRs to get the flow, and the BFER must discard the duplicate flow from the backup BFIR. When the selected BFIR fails or the path between selected BFIR and BFER fails, the BFER must switch the forwarding plane to forward the flow comes from the backup BFIR. For BFR, the intermediate node, the BFR knows nothing about the role of BFIR, just do the packet forwarding. Only in hot standby mode there is duplicate flow forwarded. It's hard to say which mode is the best way for BIER deployment. The network administrator should select the most suitable mode according to the network situation. Next, please. Now let's see what will happen when the BFIR switch over. In cold standby mode, BFER detects the failure of the selected BFIR and signals to the backup BFIR. There is packet loss during the signaling until BFER receives the flow from the backup BFIR. In warm standby mode, the backup BFIR detects the failure of the selected BFIR. That there is packet loss during the BFIR switchover. In hot standby mode, the BFER detects the failure of the selected BFIR. Because there are two flows arrive on the BFER, the BFER just switches to forward the flow comes from the backup BFIR. But there's something wrong with it because maybe the path is not worked, but the packet is still received from the selected BFIR. So this situation in fact will not happen. So we know that the packet loss occurs during the failure detection period and the switching execution. And we know that the failure detection is almost the longest part in the protection. Next, please. Failure detection includes node failure detection and path failure detection. For node failure, the period overlay signaling may be used, but we all know it's not quick. So we can do the detection through BIER layer. The backup BFIR can monitor the selected BFIR, and the BFER can also monitor the selected BFIR. The monitor can be achieved by IPv4 ping or IPv6 ping or LSP ping or BIER ping. The monitor can be done by P2P sessions such as ping, BFD, and the other ways. Because
Sandy?
there are many here. Okay.
We're really tight, and I hate to cut him off.
Okay.
All right. So
Okay.
you're going into how
Almost
each one of these operates to detect the edge, huh? Okay.
Yes, I have presented in last meeting for, in 106 meeting. Yeah. About the ping and the BFD.
All right, so those are mechanics, but I think what is very important first, what's the definition of a flow? And second, we have to look at the impact of the architecture because it looks like we start to distribute per flow state over the whole BIER fabric, which is probably not a particularly good architecture. Okay, from my side, I think those things need to be discussed out.
Okay. So let's see, who's read this draft?
This one I did not.
Okay. I did not read it in detail, but I did. It's in my complete depth queue. I went through, skimmed. So I would say, live is definitely something like protection, duplicate sources, whatever it's a live. I mean, these are real things with multi-point transports out there today. Having a solution as well with beer is going to be, I think, needed. Whether it's all fleshed out here or not, it's not really the point. But this is work I think should be moving forward. Let's do a quick hum fast. Who thinks this should be adopted?
Strong hum on my side. Yeah.
Couple of hums. I don't think the hum thing's working.
This discussion is coming up over and over again with clients running high value multicast flows. Yeah.
All right, so let's take this from the list for adoption. I'll move from there. Thank you, Sandy. Thank you very much. I'll let that thing age, and we'll go to our next presentation because we're running out of time. Liang Zheng.
Mike, is your Liang?
Running out of time really quick. So next slide, please. So a little bit of history. So the native IP v6 solution, a beer v6 solution, was proposed in 102, and there's this split of the requirement document, which is now in a stable status as a working group document. So today, in this session, we'll focus on updating you guys of the improvement we have been made from 06 to 08 version. So next slide. So for 06 version, we inherit the next header value, which is defined and allocated by INA,